Okay, so this is Leetcode number 322, that is coin change. So like what's given in the question here. Uh, Here we have the two arrays given, one array is given there which is named as the coins, in which we have to simply represent the what is the different denominations we have present here, and when the amount there we have to simply return the what are the fewest number of the coins that you need to make up that amount. Okay, so we have to given the one coins array given, and from that there are the many of the combinations possible such that their sum becomes the target, or there's another case possible that it is not possible to make any kind of combination sums equal to this amount. So we need so if we are not able to make any of the combination, we simply return -1, and in the else condition we have to seek for the return the what are the minimum number of coins required possible here, like here 1 2 5 there. If you have to start from this, so if you have to we can do what are the there are many of the combinations possible, like let's say we can take this to we can take the any of the coin infinite number of times. So that is nothing but the unbounded knapsack problem here, classical knapsack problem. So you can see one thing, one of the combination possible here is, let's say we have to take this 5 times, so 2 plus 2 plus 2 plus 2 plus 2, and 1 times this one, so plus 1, so that also gives the 11. But there's a problem in that case, in which case we have to take the at least we can say in that case we take the 6 times the number of coins using in that case. But now check whether there's any of the other case possible in which we can find even more further less number of coins there. So yeah, this is the required combinations in which the coins are used is just 3. So this is the minimalist possible there. Okay, so now come to the problem intuition, so what's given in the question. Since at every index we have the two choices, either we have to take that coin or either we have to not take the coin simply. Okay, so if we have to take the coin, we stay at the same index, or since we can reuse it, so that's why we should stay at the same index. And in the case when we are not take the coin, we simply move to the other index there. Okay, now we need to minimize the number of coins to form the target amount there. Okay, now at each step we try the both choices and take the what are the minimum possible from that cases. So whenever you have to seek, there are the multiple choices, so we have to try multiple configurations possible. So this naturally leads to the recursion, and since now afterward we have to see whether we can optimize that part or not, or that is actually needed or not there. Okay, so coming to the question, this dry run part there, there's a definition of this. First of all, what's since I had to use the recursion, so this is my definition of my state, for recursive state that I draw here. So this is nothing but the let's say I can call this as a target, but that is given as the amount here. Okay, so this is nothing what this means is, so this is nothing but the this f of comma target, it is nothing but the what are the minimum number needed to form the target value using coins, we can say from 0 to index there. Okay, so this is the meaning of this state there. And now what we need to do here, so we simply need to find the what are the minimum, if we have to start we can say this amount there. Okay, so this is the what we need to find there. We simply use since this is the using the coin wait a second there. Okay, so coin from 0 to index there, and so what we need to, we simply start from the n-1, and what's the target, we simply but just nothing but the amount there. Okay, so what's the given in this test case, it's given as a 1 2 5, there's a coins array of given here, and there's a amount is as 11. Okay, so now solve for this part. Okay, so what we need in this question, we simply need the what is the value of this as f of 2 comma 11 there. 2 means we have to start from this index there, and this is our target value there. So now check for the So this means that what's the minimum coins needed to form the 11 using coins 1, 2 and 5 there. So there's a what's the definition of this, when we have to start from here. So we can say we simply take what's the one of the cases either we have to take that, and another case is either we have to non take that, and what's the minimum is we have to give that part and take we've simply moved to our previous index, means int +1. And in the case of in non-take case, and in the take case we have to pick that current and stay at same index. So now call for this, we can say here also, you can say in the take condition we simply call this is nothing but the 1 plus f of int comma target minus, and you know very well there's a condition in what case we have take that part that it should not exceed our maximum value there. Okay, and in the non-take condition it is nothing but the index -1 there, and this is the target value. Target remains same there in case of not taking. Okay, so this is the case and this is the value of the take and not take. Now call for the recursion tree there. Okay, so now call for the f of 2,11. So there's a two conditions, either we have to non-take or this take. So this is for the non-take, this is for the take. If we have to non-take, we simply moves to previous index, means f of 1, and target remain the same there. In the take condition we stay as this index, but now our target decreases by the 5. Okay, now again the two choices, either we have to not take or to take there. So not take, we simply move to 0, and this is the case 1,9. Now similarly for this, and now simply we do for whenever I am talking about this state f of 1,7, since we reaching to the index number 1,7, and now there's only cases possible, either we have to not take or either if we have stand here and we have to call for the either we have to not take or the take position. So similarly this goes on you don't go below, it is also possible that we don't have to take this part. So in that case it's nothing but the f of so it goes to 0 there, and the target remain the same, and this trees goes on there, but we not need to make it this is the and what we need to see here. So there during the forming of the whole of the tree, we see there are the many of the states that are repeating again and again there. If you draw for the very last test case, you see very well some of the states are simply repeating. So we can say there are the repetition multiple times. So this shows us the overlapping subproblems. So to avoid this recomputation every time, we simply store that, and for the storing we simply use the dp vector. So that's why now this leads to use of the dp vector. So now call for the brute force code, or again here I am calling explain you what's the base case for this recursion there, so don't worry about it. So this is simply the main function here. I initialize the size, this is for the answer. Since there the question it is given if you are not able to make any of the combination such that the sum becomes amount, simply represent -1. Okay, so to handle those cases we simply first of all store our answer here, and in the definition of the solve we see we will see there if this is not possible, represent infinity there. So whenever our answer is infinity, so we represent -1. It's nothing but it means we are not able to make any of the combination, and in the else condition we simply return that answer there. Now this is the definition of solve function. We pass index comma target there on the coins skip that base case for now. This one condition when we not take, and this take condition, since we are not guaranteed that it is possible we have to take that or not. So let's initialize with maximum. So why maximum? Because since we have to take minimum of this, so to make it escapable or don't account it, we simply initialize with maximum part there. and like a check if it is, we can put this like coins of index is less than equal to target, means we can take that part. So take that take is equal to 1 plus, and so simply add 1 plus, because we have to simply return the number of combination, that's for 1 plus, and the solve index remains same, target decreases by this, and simply result minimum of whatever the take and not take. Now come to the base case there. Since we start from the index at the ending n-1 and now reaching to the starting of our array, like we have to traverse from such that like we have to traverse from this ending and now goes to the starting there. So since if I have to reach to the 0th index, so what are the case possible here? So in that case we have to see what are the things possible here, whether we can take that part or not take part. Okay, so this is a base case. If index is equal to 0 means we are starting at the index. So we can see one thing, if our target value and if our the points of 0 means what are the points is situated at here, if it is we can take that part, like we are allowed to take that part, so we simply return what are the target by coins of 0, and in else condition we simply, if we are not able, we simply return the infinity part. Like I can explain you through example. So if I'm talking about this, let's say, okay, so I'm talking using this test case again. So this is nothing but the what is the array given here. So this array is given as a 1, 2, 2, and this a 5. Okay, and like if we are standing at this f of if we have to start from this f of n-1, now it call for the previous state. Now let's say if I reach at this 0th index, so like since we have to judge from here, because it doesn't go beyond it, since we have to return the number of combinations, so we have to check for the base case. For this base case is required, as we have called for the recursion there. Okay, so now we see one thing there, that I can say one thing, let's say if we are reaching to our index is equal to 0, so what thing possible here, like in whenever we, in what condition we have to take that part. Let's say target remaining is something we can say okay, let's say I'm talking about the sum of the test case. If I'm talking about this, let's say it becomes the 3. Let's assume I'm talking about this test case there. This is nothing but the 6 or this is nothing but the 8 there. Okay, now for target also you can say the amount is nothing but the this amount is nothing but the 18. Okay, now let's say any of the amount here. Okay, so since I have to start from it, we have to reach when we are standing at the 0th index, and let's say the amount remaining here, like we can say the what are the amount remaining, or we can say also the target remaining here is, if target remaining is a 7. Okay, and you are standing at 0th position, so we see very well, like it is not possible, like if we can not take how many of the combinations of, like you can use how many of the many of the times of you can use 3, but we can't make it sum as it's 7. Like let's say it is given as the 9 here, and you are standing at this 3, so simply we can take this 3 as a 3 3 3, so means you can take the 3 as 3 times means, so like we are standing at that position, so we simply divide. If our target value is, if it is divisible, we can say if it is divisible by our nums of 0th array, or we can say since it is index at 0, so we can say index 0, or we can say 0th index is nothing but say. Okay, so if it becomes 0, it's divisible, its remainder becomes 0, so what it means it simply divided it completely. So in what condition it completely, so it means we can, it is possible to make the using the many of the occurrences of nums 0 such that is sum become the target value. So in that case we simply written what are the possible cases here. It's nothing but the, like I represent here, I can say here target by the nums of 0 there. Okay, So this is the possible cases. So like as I call you, let's say I have number, let's say I'm calling about here. Okay, if let's say our nums of 0 is nothing but the 2 here, okay, and the what are the target here is nothing but the let's say 8 here, okay. So can we meet this requirement? Oh yeah, so we can take this requirement. We can take this 2 as multiple times, like you can this 2 then 2 then 2 then 2. So what it means, we can take we can take the nums of 0 4 times to meet target there, okay. So this is possible here. So how we do this 4 times? So this is nothing but the target divided by that nums of 0, okay. Now let's say similar questions is similar case is given here, but in that condition it is nothing but the target value is given as the let's say 11. Now it is impossible to make that 11, like if you have to take the 2 then 2 then 2 then 2 then 2, but 1 is remaining there. So in that case it is not possible, so that's why we simply return the infinity. So this is for the checking at when we reach to our index is equal to 0, okay. So this is the case for here, and okay, and whenever you have to check let's say, wait a second here, let's say you don't have to confuse it if you're thinking that we can say one thing. If we think why we don't using this test case, this base case doesn't why it is not included in our base case. So if you're thinking like why this is not included, if let's say during traversing at the any of the mid position we are able to meet our requirement, so why we go to here, okay. So like don't confuse it, because whenever we have to talk about this test case, this also include this again, because you can say if we have to start if our target becomes 0, so this is nothing but becomes a 0, so we simply return this part. So 0 by something is simply becomes the 0. So that's why we are not taking that pulse again. It is already included in the already handled by this base case. So that's why we avoid the separate base case of target is equal to 0, or we can take that pulse also, it doesn't matter there, it doesn't affect our answer, okay. But like since this is for the brute force, since each state has a two choices there, so total states are n there, and like so total complexity become 2 power n there, okay. So this is exponential, it gives a TLE with this constraint there. So and discuss about the space complexity. So we don't use any of the extra stuff there, but this is of the for the recursion stuff, recursion stack there. So of target, because in the worst condition we have to meet all of the states, that's why this goes on to whole. So let's take off target there. Now to optimize it, we simply use DP. In DP we go for the memoization version. So here it is nothing but the same, we simply use the DP vector here, since the two things are vary here, one of the index and again other is the target or amount, we can say target or amount, whatever the. So you can say index or target, and what is the possible offset, or you can say what are the possible limit for this target. So this doesn't goes beyond the amount. So to save case we use amount plus 1, because target goes to 0 to amount, so that becomes amount plus 1, that's why. So this is our DP vector here, simply include this in our main function. This is for checking whether it is already stored in not, and simply store this value in our DB vector and return that part, okay. So time complexity is nothing but this is for since n into amount, so this is for the time complexity. Again is space complexity for using this vector there, and this is for the recursion stack there. So thank you for this question.